So thank you, team, for coming and dealing with this whole coronavirus thing and our transition to Zoom for final demo day. We're really excited to see your final project. I'm sure the judges are too. So just as a little reminder, you'll have about 7 minutes for your presentation. I'll write down in the chat when you have like about a minute left. Then we'll watch your video. We'll all watch it individually on our own computers. Then when we're done with that, we'll come back and you'll have a Q&A session for the remainder of the 30 minutes. Okay. Sounds good?
Awesome. Yeah.
Okay, great. So whenever you're ready, you can go ahead and start.
Okay. Well, good morning, everybody. We are Team 2, Doc Division. My name is Dante. I'm here with my partners Inbar, Arush, and Ben. And our advisor is Dr. James Wan.
So I want everyone to take a moment and think about your last visit to the doctor's office or to the hospital. Most likely you experienced what the majority of patients feel, a disconnect in the relationship between you and your doctor. The interaction between patients and medical personnel is negatively affected by lack of maintaining eye contact as doctors focus on reviewing clipboards, surrounding machines, and jotting down notes, all while on a busy schedule. As we dug deeper into this issue of lack of complete interaction, we found secondary problems of misidentification and the cumbersome two-step verification process. 62% of misidentification of patients is due to just having a hard time finding the chart. And then the two-step verification process involves two nurses coming in, taking turns asking you your name, which adds extra workload, cost, and doesn't guarantee proper identification. Misidentification of patient or proper side for a procedure has led to hundreds of errors, ranging from diagnosing the wrong person to performing an X-ray on the wrong side, and that's only in the radiology department. So for these problems, we realized there was an overall need to improve patient-doctor interaction as well as the patient identification process in order to improve the overall experience. And now Arush will continue talking about our motivation.
So throughout our design process, we talked to many stakeholders to ensure we built a product that would be successful. From speaking with executives at United Health Group, we found that they pay out an average of $242,000 per malpractice lawsuit. And from speaking to a quality engineer at CHOP, we found that hospitals spend an estimate of $45 billion a year on defensive procedures against malpractice. With those staggering numbers in mind, we believe we could create a device that would significantly decrease misidentification-related malpractice suits. So then, keeping in mind with our doctor-patient interaction goal, we looked at different leading AR solutions such as Google Glass, Focals, and HoloLens, and spoke to the lead engineer at Focals, and found that none were designed specifically for the medical space. So our goal was to create an AR device to improve the interaction with the patient identification process and improve the whole overall experience.
Introducing Doctor Vision, a fully enclosed attachment for glasses that create AR goggles that will help medical professionals with the issues that we mentioned before. Visually going through our device and beginning at the front, we have the ArduCam that uses facial recognition to identify our patient. This camera is connected to a Pi Zero that is powered by its counterpart, the Pi Sugar. The Pi Zero interacts with our database to collect the patient information. And the button on the side is the user interface that brings the entire device together. It brings up and removes the display of the patient information on the OLED transparent display, which helps the doctor to maintain eye contact. And we designed our device to work efficiently and effectively. So some specifications that we had while we were designing were to keep the facial recognition under 5 seconds and to have our device pull in that data from our database in under 2 seconds. And now Ben will explain the process that a doctor will take while using our device.
Thanks, Doctor. So first, when the patient is admitted to the hospital, they would have their picture taken to train our model, which takes less than 20 seconds. And then when the doctor wants to start the checkup, they first flip the device around and point the glasses at themselves so that we use the camera using facial recognition can log the doctor in to ensure that only our approved list of doctors gain access to our system. So then the doctor puts the glasses back on, and using our facial recognition, the glasses can recognize the patient. Once the patient is recognized, as Dante mentioned, takes less than 5 seconds, the patient's chart is pulled from our secure and encrypted Google Cloud database, and their information is shown on our display. The doctor then proceeds as they normally would in any other type of checkup, and at the end of the visit, the doctor can update the patient's information using onboard buttons, and the new information is saved and sent back to our database. And whenever the doctor is finished, they can close out of that patient's information by clicking a button, ensuring that no unauthorized users can access any patient data. And as you can see, we have designed our product while both considering privacy and engineering standards and specifications. We use a secure database, which includes both password protection and encryption, and we only allow approved users to gain access to the system. Doctors log in by facial recognition, and they log out when the session's over. And for standards, we looked at HIPAA legislation and IEEE medical device requirements to ensure our product fit industry standards.
We've all had a poor experience at a doctor's office at some point where the doctor spends the entire time looking at a computer and you wonder why you wasted hundreds of dollars to be there. From that simple case to the more extreme, where a patient is misidentified and is administered the wrong drug or procedure, we built Dr. Vision to help fundamentally improve the doctor-patient relationship and the entire identification process. It will help doctors streamline their workflow, improve patients' experience, and reduce malpractice cases for insurance companies and hospitals. It has the potential to significantly reduce costs for hospitals, paying for itself multiple times over. By talking to hospitals, insurance companies, and medical device companies, we believe we have created an ethical product that will both be successful in the market and can help improve patient outcomes. Thank you all for your time today, and we're open to questions.
Awesome. Thank you, team, for your presentation. The judges are now going to go ahead and watch your demo video. And then judges, when you're done, just write done in the chat.